Hey, everybody. So we're looking at the 15.1 worksheet today. This deals with both part one and part two of this section. Part one being the central angles, part two being the inscribed angles. And you can see the front side deals with the central and the back side, deals with the inscribed angles. Alrighty. So yeah, let's just jump into it and I'll remind you of the rules here. The first section is just asking us if we have a major arc or a minor arc and a semicircle. All right. And yeah, remember it all revolves around 180. Minor arcs are less than 180, major greater than 180, semicircle equal to 180. Okay, so I'm going to take a look at number three here. Arc EAC is what they're asking us to find. So that arc starts at E, goes through A, all the way to C. Okay, and you guys can see, just by looking at it, this is an arc that goes from one end of a diameter to the other. This is a semicircle, right? Okay, so yeah, just go through there. Just take a look, and it'll be pretty obvious whether it's less than 180 or greater than 180 or equal. All right. Moving down to the next section. This is asking us to find, the measure of a bunch of arcs. The first thing they're telling us is that PR and QS, those segments are diameters. And we can see that just by looking at these, those are straight segments going through the center of the circle. So, that's good to know, but we can see it on the circle. Okay, take a look at number 9. They want the measure of arc PQ. Let me highlight it. There is the arc we're asked to find. Okay, so here's what I'm thinking. If I can find this central angle, I will be able to get the measure of this arc because remember, the measure of a central angle and its intercepted arc are the same. All right. So how can I find the measure of this angle right here? Well, here's probably the quickest, straightforward way. These angles here and here are vertical angles. Okay, and that means they're the same. If this is 42, we know that this is 42 and that means this is 42. Okay, and there it is. Okay, I highly recommend as you go through this entire worksheet, whenever you get new information, put it onto your circle because I might need to know this arc is 42 for another problem down the line. Okay, but yeah, I'm going to leave that to you. Again, look out for the diameters, cutting the thing into semicircles, 180 halves. That is a big way of getting some of these problems. And also remember that a circle is 360 degrees. Okay, so just for example, if they wanted me to find this whole arc right here, we'd be able to take 360, subtract 42, and we'd have that. All right, I'm not sure if that's actually a question here, but just remember that is something that happens. Okay. All right. Go ahead and jump down to number 19. I had the answer there. So these are weird. 19 and 20 are just kind of out of left field. Here's what they're saying. Arc PQ has a measure of 90 degrees. Okay, so they're telling me this arc right here is 90. Okay, here's what they want me to find. The length of segment PQ. Okay, so they want me to find this segment right here. Okay, and we haven't actually had any problems that had us find something like this. Okay, so let's just kind of walk our way and get as much information on this as we can, and then we'll see what we can do. Okay, so here's the first thing I notice. If this arc is 90 degrees, that means this central angle is also 90 degrees, or in other words, it's a right angle. Okay, here's the next thing. This segment that goes from the center to the edge of the circle is called a radius. All radiuses on a circle are the same measure. If this is 7, this is 7. Okay, so there's a couple ways of doing this, or getting our answer from this information, but here's what I want you to realize. These congruent sides on a right angle or a right triangle tell us that this is a 45, 45, 90 triangle. Okay, this is a 45-degree angle, and this is a 45-degree angle. Okay, and if you guys remember, that's a special right triangle. All right, and we had a rule for our special right triangles. We could get the hypotenuse using, the legs of our triangle. All we had to do is multiply it by the square root of 2. Okay, and there it is. If this leg is 7, this hypotenuse is a 7 square root of 2. Okay, so there's your answer. Okay, and just by the way, we could have also used like the Pythagorean theorem to find this. We could have also used trig to find this side length. There's a bunch of ways we know how to find that side length. I think the special right triangle is the quickest and maybe the most interesting. Okay, moving down to these last problems here. These all revolve around mainly the idea that a circle is 360 degrees. So here's what they're asking for on number 21, the measure of arc AC. So just this arc right here. Okay, here's what they're showing us. So this is important. This arc and this arc are the same measure. They're congruent. Okay, so let's get what we know. We know that if this is 90-degree central angle, this is a 90-degree arc. Okay, and from here, we can take that number and we can subtract it from 360 to get the rest of the circle. Okay, the rest of the circle. So if we take 360, subtract 90, we're going to get 270. Okay, that's what the entire, rest of the circle is, and the two parts are congruent. So if we take that number and cut it in half, okay, we're going to get our answer. Okay, and I'll let you do that on your own. So go ahead and divide that, and you'll have number 21. Okay, cool. So from here on the backside, we're getting into using the inscribed angles. Take a look at number 2. All right, this one is asking us to find the measure of arc ST. Okay, so let me highlight that. They just want the measure of this arc right here. Okay, cool. So, what do we know? We know the measure of this inscribed angle right here, 61 degrees. Okay, if you guys remember, the rule is that an inscribed angle, its measure is half the measure of its intercepted arc. Okay, so 61 is half the measure of this arc, or this arc is double the measure of this angle. Okay, so that's going to give me 122 degrees, right? Okay, that's not what they asked for, but now what I can do is I can take 180, I guess the big thing to maybe realize, this is a diameter and this entire arc here is 180 degrees, right? So we can take 180, we can subtract 122, and we can find our missing angle. It looks like what? It's going to be 58 degrees. Okay. And when you guys get your answer on these, put it off to the side, put a box around it just to make it obvious. Okay. And yeah, that's again kind of the idea. Look for diameters. There's a lot of diameters on these problems. Okay. Though I do want to look at one that doesn't have one. Take a look at number 7. Okay. This is asking for arc VST. So starting at V, going through S all the way to T. Let me make that a different color. Okay, so VST, that's what we're looking for. All right. We have part of it. We can see that this part of our arc right here is 39 degrees. Okay, so what I'm thinking is if I can find the rest of this arc, I can add those together and I'll have the whole thing. Okay, so how can I do that? All right, well, here is one piece of information I can see. We have this inscribed angle. Okay, and I know the measure of this angle is half the measure of this intercepted arc, or the arc is double the angle. If this is 51, this is 102. Okay, and then from here, I can take the fact that a circle is 360 degrees. And if I subtract these three measures for these arcs, I'm going to get this purple arc right here. Okay, I'm going to get arc ST. Okay, there's the bell. Okay, so taking subtracting 102, 135, 39. Okay, go ahead and subtract all those numbers with your calculator. I'll let you do that. When you do, that number is going to be the measure of arc ST. Okay, that's not what they're asking for though, right? You'll then need to add together those two to get the entire arc. Okay, but I'm gonna let you do some of that work. Alrighty, it's cool. I just have a couple more to take a look at. So take a look at numbers 8 and 9. First thing on these problems, they're giving us some information in the directions. We should put that onto our shape. Okay, so first thing they're telling us, they're, I guess this is the first big thing. Arc LM is 84. So let me highlight it. LM, this one right here, 84. Okay, other thing, arc KN is 116. So from K to N. By the way, I know these are minor arcs, the shortest distance because they're just naming them with two letters. That's why I know I am not going all the way around the circle because then it would be a major arc and it would have been named with three letters. Okay, so anyway, this is 116. Okay, so taking a look at number 8, they're asking you to find the measure of an angle, okay, angle JKL. All right, for some people, identifying where that angle is might be the hard part. Okay, so JKL, just a reminder, that starts at J, goes around K to L. This is angle JKL. Okay, that's what we're asked to find. All right, here's the thing we got to realize. This is part of an inscribed triangle. Okay. And one of the side lengths of this inscribed triangle is a diameter. Okay. And if you guys remember, the rule is, or I guess the theorem is that if we have an inscribed triangle with a diameter as a side length, it's a right triangle. Okay. So this is actually a 90-degree right angle. All right. And that, is my answer on this one. Okay. Cool. So from here, number 9 is asking us to find the measure of MKL. All right. So let's figure out where that's at. MKL starts at M, goes around K to L. We're talking about just this part of this angle. All right. Here's the big theme of this entire, worksheet. This is an inscribed angle. And if we can figure out its intercepted arc, we can use the rule. We can take a half of it. And if you guys follow the side lengths of this angle, you'll notice its intercepted arc, we already know. It's 84, right? So the idea is we can take a half of 84 and we can get that this angle here is going to be 42 degrees. Okay. And, the theme of this is these are going to kind of build on to one another. So, number 10, the fact that we have all of this info on here is really important. We probably need to know that this is a 42-degree angle to get some of these other answers. Okay, cool. So yeah, try those out. If you have any questions, let me know.